Hi, everybody. Good morning. Thank you for having me here to talk. My talk today is going to be about Lalo, which is also known as French frigate shoals, threats it faces going into the future, as well as the green turtles that utilize it as nesting habitat. Lalo is a very important place to me. I've spent the last 3 summers working there in a remote field camp, and I'm excited to start my talk. So the honu, or the Hawaiian green sea turtle, is part of a threatened genetically distinct subpopulation that is native to Hawaiian waters. It's estimated that these turtles reach sexual maturity at around 30 years old and reproduce every 2 to 5 years after that at their natal nesting beaches. These turtles also display a rare basking behavior that is only seen in 2 other places in the world. What's important to know about sea turtles as well is that they display what's called temperature-dependent sex determination. This means that as the embryo is developing within the egg, temperature gives it the cue to turn male or female, with warmer nests producing more female hatchlings. So this has a lot of major implications for all sea turtle species in regards to climate change. Focusing on Lalo, Lalo is located 500 miles west of Oahu, and what makes it super important is that 96% of all Hawaiian green sea turtle nesting takes place there. There is some nesting in the main Hawaiian Islands and further up the chain in the monument, but Lalo is the stronghold for the Hawaiian green sea turtle. Focusing even more on Lalo, it's an atoll of low-lying islets. Some of the islets are ephemeral and others are more stable. And there's 2 main sea turtle nesting sites there. There's Turn Island to the north and East Island right in the middle. And these islets are 7 miles apart for scale. Lalo is also known as French frigate shoals and was heavily utilized by the US government since the 1930s. East and Turn Island were also historically heavily manipulated and used to support infrastructure. At this point, Turn Island is almost entirely man-made, and it used to support a runway and US Fish and Wildlife Field Station that were both last used in 2012. Lalo is an incredible place. It's very important culturally as well as biologically. It's home to the Hawaiian monk seal as well as numerous seabird colonies. I feel incredibly lucky that I'm able to access the atoll and work in such a special place. So focusing on East Island historically was the main sea turtle nesting site in all of Hawaii. There's a great data set that studies nesting females there stretching back to the 1970s. Unfortunately, though, the island was wiped out in one significant storm event. So in 2018, Hurricane Walaka made a direct impact on the island and took a 3 to 4 hectare vegetated islet and reduced it to a small sandbar in one evening. These storm events really do highlight the fragility of this population because almost all the nesting is taking place on these small, low-lying islets. Fortunately, though, the East Island did start to build up over the years. And this is an overlay with tracks from 2018 and 2024, and the island is currently 2/3 of its pre-hurricane size. It doesn't have any more vegetation, and we're not sure if the island will continue to grow or if it is stabilized. But what is some of the field camp research that is taking place up at Lalo? So while we're there, our 2 main focuses are population monitoring and studying the honu's resiliency to climate change. Population monitoring entails getting out to the atoll, counting and IDing as many individual turtles as we can so we can get a good count on this breeding cohort that's using the atoll for that season. So this means doing nesting surveys at night, basking surveys during the day as well. Additionally, we're looking at the turtles' nest success. So we'll mark nests, dig them up after they've hatched, count their contents to gauge hatchling production. Additionally, we're doing some really interesting research in regards to climate change. We're using satellite telemetry to track turtles to see how they've reacted to the loss of emergent land, as well as looking at nest incubation temperatures and hatchling sex ratios. The work there can be pretty demanding. You're working the night shift with red lights, putting in data loggers and nests, and also working during the day. But it's a pretty incredible experience, and you get awesome hands-on opportunities with adult sea turtles and hatchlings as well. I can't think of a better way to spend a summer, to be honest. And speaking of which, We are looking for applicants for our 2025 season, so if you know anybody who's really into sea turtles, please encourage them to apply. So this is a graph of that data set that I mentioned that goes back to the 70s. This is primarily focused on East Island nesting females, and it displays a 3 to 5% increase in the number of nesting females on East Island over time. The data, though, does get a little bit murky in 2018 during the hurricane, because the field collection site had to switch to Tern Island, which historically received less nesters. Luckily, though, East Island is built up again and is starting to look a little bit more stable, so we're excited to get a field team back to East Island to collect data there for the whole season and add to this great data set. So what are some major threats facing Lalo? I would say the biggest threat is the erosion and loss of emergent land. If there's no emergent land, there's no place for seals, turtles, and birds to reproduce. Another threat would be the overall degradation of the nesting habitat, and this is primarily an issue on Tern Island. Additionally, another threat are the long-term effects of climate change. I kind of touched on some of them earlier in the talk, but this could include sea level rise, nest inundation, and a variety of other issues. So terrestrial habitat loss and erosion is nothing new at Lalo. In the 60s, there was Trigg Island and Whaleskate Island. These were large vegetated islets. But by the early to mid-2000s, they'd been reduced to small emergent sandbars. Soon after these pictures were taken, they eroded and have not returned. Another issue at Tern Island is the degrading habitat quality in Lalo. All these pictures are taken on Tern Island, and like I mentioned before, Tern is practically man-made at this point, so as it erodes, it exposes lots of crumbling seawall, concrete slabs, old barrels, and even heavy equipment, all of which could be hazards to the wildlife that use Lalo. So focusing on that erosion on Tern, from 2018 to 2024, we estimate that a half hectare of sea turtle nesting habitat has been lost. This equates to roughly a football field. Additionally, when the hurricane hit, it wiped out all the woody vegetation along Tern's South Beach. So we're seeing consistent erosion in this area, though there is some stability in its southwestern corner. This map zooms in on Tern's South Beach. We have track lines from 2020, 2022, and 2024 tracking the berm of the island. And this is an area where we're seeing that slow creeping erosion year after year, with sand being pulled off the beach and drifting west. This map zooms into Tern's southwest corner. It has the same track lines from the same years. And this is an area where we're actually seeing some accretion. So the beach is slightly building up in this area. And there is some pre-existing shoreline stabilization structures that could be aiding in this. This picture is a really good representation of the erosion that's happening on Tern. The picture on the left is from 2019 and the right 2024. And you can just really see how much sand has been lost, and this is actually becoming a major entrapment hazard for turtles. Here's another area that has lost a lot of sand that is also a turtle hazard. So what does the nesting habitat look like on Tern Island? Well, on this map, the yellow represents the active nesting habitat. This is where we know turtles are currently digging and laying eggs. And the black on the map represents walls or obstructions. This can be exposed seawalls or cliffs. We estimate that 45% of the beach on Tern's south side has some form of obstruction that is preventing turtles from effectively reaching the nesting habitat above. Additionally, on this map, in the orange, we have some concrete structures, old buildings and concrete slabs, and the blue is the old runway. It's important to note that the runway is made of super densely packed coral rubble and sand, and it's so compacted that the turtles cannot dig there or lay eggs. This is what some of the obstructions look like. This picture has some cliffs and exposed seawall. The cliffs can be up to 8 feet high. Here's an area that has these concrete slabs. This is an area of exposed seawall that has 3 sea turtles trapped behind it. Part of our job while we're up in the atoll is every day we do a sweep of Tern Island to look for entrapped animals, and if they're stuck, we'll help them get back to sea. Additionally, we've noticed a shift in the nesting habitat in recent years. On this slide, there's heat maps from 2019 and 2023 using sea turtle nesting data. So in 2019, there was available nesting sites all along Tern's South Beach, and over time, we've seen kind of like a dead zone develop in this area where there's a lot of obstructions. So density is increased on either side of this dead zone, And we're seeing nests being laid in closer proximity to each other. And now turtles are, it's becoming really common to see turtles inadvertently digging up each other's nest and crushing the eggs. So it does start to make you wonder if tern is slowly reaching its nesting carrying capacity as the habitat shrinks. So what are some possible future mitigation options? And these are just some suggestions and things that are being tossed around by managers. So an easy one that could be done on Tern Island would be to continue our ongoing entrapment hazard reduction. This would involve cutting holes in areas of crumbling seawall, so if an animal does get stuck, it can get out, removing large piles of debris on the nesting beach, and also blocking up these higher cliff areas so animals don't fall off them. Getting into the more labor-intensive and logistically challenging solutions, you could look into shoreline stabilization. This would involve reintroducing native or naturalized plant species, and then fracturing parts of the runway or removing sections to expand the nesting habitat and allow those roots to take hold. It is important to note that like any island, Lalo is part of a delicate ecosystem that would require strict biosecurity measures to prevent the introduction of invasive species. And you can see these pictures on the left are taken in the same spot, and the beach has drastically changed in just 5 years. Getting into the very logistically challenging solutions, you could look into something like beach renourishment. This would involve replenishing sand on Tern's South Beach. This would be pretty difficult, and you'd have to make sure that the sand grain size is appropriate for sea turtle nesting substrate, as well as if you were going to bring sand in or source it locally. And there's also a lot of coral reefs surrounding this area, so you wouldn't want to make increase the water's turbidity too much. Like I mentioned before, Tern Island already has an erosion problem, so there's a lot of questions about if a project like this could even be successful. A way to combat this erosion problem would to partner this with shoreline stabilization structures. This would involve building groins or jetties along Tern's South Beach to help slow down the erosion and trap sand. This also has a whole host of logistical challenges involving a tremendous amount of moving a tremendous amount of material and heavy equipment and a workforce 500 miles west into Lalo. So while these projects can sound daunting and almost impossible, they have been done in the past and they are technically feasible, just complicated and expensive. So currently, Tern Island's perimeter is mostly made up of reinforced seawall and riprap. So this picture is actually taken in Tern's southwest corner, and there's a Hawaiian monk seal and a turtle using this beach. It is important to note that further construction of these shoreline stabilization structures could potentially cut off access to some of the nesting beaches. And probably the most difficult and labor-intensive would be assisted migration. This would involve moving breeders or eggs to more stable areas within the Hawaiian Islands to establish new rookeries, with the hopes that hatchlings would hatch in these new areas that are less affected by climate change, imprint there, and return upon maturity. This is incredibly logistically complex, just based on the turtle's biological limitations. And finally, you could look into returning Tern back to its natural state. So prior to its development, Tern resembled East Island, and this would involve removing all infrastructure, seawalls, and filling in its dredged channels. But we're not sure if it would even allow the island to stabilize or if it would wash away. So in conclusion, there's a major uncertain future for Lalo. We're not sure how long there will be emergent land there, or if the turtles can adapt faster than the climate will change. Additionally, mitigation looks to be a complex combination of a lot of expensive different approaches, and we'll need hydrologists and coastal engineers to better inform decision-making. Additionally, it could take up to 30 years to gauge the success of these mitigation methods just based on turtle biology. I want to say thank you for allowing me to give the talk, and if you have any questions, feel free to find me or seek out some of my colleagues at their Lalo-themed posters. Thank you.